Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, part 13 of the Robo Hat series, I'm going to cover the ADS1115. So the ADS1115 is a 4-channel 16-bit analog to digital converter, and on the Robo Hat I've got 2 of those installed. And they are located here and here on the board. So 2 very small chips, and they're not that difficult to drive once you get the hang of it. So let's bring up Thonny just to cover the hardware side of it. This is a 5-way strip of wires. I've connected 3 wires to the ADS1115 pins on the board. I've got VCC, which is 3.3 volt in this version. Over here we've got ground, and port 0 I've connected to the middle pin on a pot. So I'm using that in that configuration as a voltage divider between 0 volt and 3.3 volt. So let's start up Thonny. And I've started using SM Bus 2. So in my previous 2 videos, I was using SM Bus, the original version. I have now updated them all to use SM Bus 2. And in this we create an object. In this case it's the I2C bus, and I'm using bus 1 because that's the one we need to use on the Raspberry Pis. If you were doing something similar to this on an Arduino, you'd be using bus 0. Device address for the ADS1115, it has 4 possible addresses starting at 0x48, 0x49, 0x4A and 0x4B. On this board we're just using 48 and 49 as was visible in the scan up here. So in the program there's only 4 registers that we can use. But these are 16-bit registers, so you just need to be aware of that one. We have the conversion register, which is where we actually get our data from. We have the config register, a low threshold register and a high threshold register. Now in this example we're not going to use the low or high threshold registers. They activate the interrupt output on this chip, which we are not using. It's not connected. So we'll only be using the conversion register, which is where we read our data, and the config register where we set it up. I've actually, just for reference, put in what all the bits in the configuration register are and what they do. We have, I've created a function called readChannel, and it will return the value that it reads. The config, I'm using this configuration where the first or the most significant bit is turned on and the 2 least significant bits are on. We then add into it the channel, the gain and the rate bits. So if we go back up here, the lowest 2 are comparator and Q. We've Q's only got 1 U there. We've disabled the comparator on it because we're not using it. It's that simple. The comparator uses the low and high threshold and we're not using those. The data rate we take in and we do a bit of magic to it. In this case the data rate is shifted 5 bits across, and that's these ones here. And if we look down here we've got gain, which is done through here. We shifted it 9, which sets our gain. Okay, so once we've set our configuration, that will actually trigger it to do a single operation, like a single shot read. And bit 5 is one, or bit 15, the most significant bit, is a one shot. So one shot conversion. Down here, we actually write that information to the config register. Now the data coming back is 16 bits, but we do it as two 8-bit values. So we read the data from the I2C device. Device address is the one that we saved right up at the very top here. Device address, in this case 0x48. We tell it to read the conversion register. So this is after we've written to the configuration register. We read the conversion register for 2 bytes. And we look at the what we're going to do is we're going to take the least significant byte and we're going to load up LSB with this value based on the gain that we chose. We're going to then convert all of that to a float after we've shifted the data 0. So it comes back as data 0 and data 1, 2 bytes. We shift the least significant value to the right, and then we add in the right value, the second one that we come through, which gives us a 16-bit value. We convert that to a float and we multiply it by LSB. The result we then return. So in here I've done while true, and I'm just reading out each of the channels for 4 channels and reporting them back. So let's execute this program and see what we get. So you can see here we've got a floating value on channels 1, 2 and 3 of around about 0.5 volt. Channel 1 we've got at 1.682 volts. And if I turn the potentiometer that I've got connected here, you can see that the voltage on channel 0 is now changing. So it's turning it down. And I can rotate around the other way slowly and turn that value up. Okay, so things that we can use that for include connecting it to a hall sensor. This is probably not the best example hall sensor, but the ones that are used in, say, the InMove robot hand fingers are an analog output, and we can actually read the value coming off that to sense the strength of the magnetic field that it's detecting. Alright, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP patrons Go Lucky and Copernicus, All Access patron Jeff Jerd, my Builder patrons Al Morales 45, Andrew Cardone, Airgar69 and Stefan Paps in supporting the channel. I also have YouTube memberships, and you can join by clicking on the join button on the YouTube video. If you've got any questions, feel free to leave a comment below or drop into the Discord. There will be a link in the description, and you can ask your question there and I'll do my best to answer it. If I can't, someone else might be able to. And we'll see you in the next video.